So we will start with it's recording. Okay. Sorry. We will start with a new project, a new blank project. So you launch the engine, and why not starting with a pre-made template? It's because the goal is to make a real final game. It's not just experimenting and testing. The templates are very useful if you want to quickly iterate on ideas, but I prefer to start with a blank project. So you go in game, you select a blank project. Blueprint will be okay because it's easier to set up and we will not have any needs for C++ at the moment, and have the starter content inside. It will be required because we will use some of the content that you can find in the starter content. Ray tracing, it's like the blueprint. You can change the parameter later in your game project. It's not that complicated to jump from blueprint project to C++ project. And for the ray tracing, I don't have a RTX graphic card, so I don't use it, but do whatever you want. Also, it's possible to change it inside the project setting later. For the game name, we call it MakeSenS English, and create. So the first things, let me wait for the game to be created. The first thing we will do is to change some parameters for the editor, in the editor preferences and the project settings. So when you have the game launched, we can dismiss this. I'm using 2 screen for working, and we need 1 Windows content browser video. Where? Okay. Let's dock this here. Yeah, I was saying I'm using 2 screen when I'm working, but here, as I'm recording, it will be on everything on the same screen. Let's go first in the project settings, and in the rendering settings. So you can see I have a pretty old computer, and even the basic map with the terrain, it's running at 40 FPS. It's not much, and it's not the final game, it's just working on the game, so I prefer to have the best performances possible. And for that, I will disable Lumen and disable the virtual shadow maps. What else? We can remove the... I'm making a game with only real-time shadow. So halo static lighting will be off. We will restart, okay. And already you can see that we gain a few frames per second. It's already more fluid. And there is another impacting parameter. It's the anti-aliasing method. So if you go with the old and ugly FXAA, you will see that we are gaining a lot of performances. So I think we can change some other parameters. An useful functionality, when you select an object in the editor, you can press F to focus and to go close to this object. Here, if we can try to play in the game, you see that I have to first click on the screen before having control inside the game. And the game, it's already possible to play inside the game, even if we didn't make any asset, any game elements, such as the game mode, the controller and the character. It's because they are default once in the game. By default, you have a controller and a pawn. This is my cheating. My cheating Unreal project. So I will put it here to be able to take a look when I don't remember something. And what I was saying is, yeah, there are a few other parameters to change. For example, having directly the control inside when you start playing the game. Game get mouse, yeah, game gets mouse control. So now if I play, you see I directly have the control, I don't have to click on the screen, on the viewport. What else to modify? Yeah, current cam location. No, it's not here. It's here. Yeah. I prefer to start where I am in the editor rather than using the player start. It's just my preferences. You are free to do the way you prefer. I'm just showing it so you know there is a possibility to change these parameters. Also something I don't like, for example, now if I start playing, instead of starting from this element, the player start, I start from where the camera is in the editor. So that's useful for, I prefer this way. But when I stop, you see that my editor camera have been moved at the place I stopped playing. I was here when I started and I arrived here. This is something I don't like. I prefer to go back from the in-game session at the place I was when I started. For this, you also have a parameter. I also have cheating notes. Of course, I prepared this video even if I'm improvising for being more natural rather than reciting a text. I prepared a lot. Yeah, this is the parameter. Use camera location play from play in viewport. I turn this off. Also something that I don't like is when you start the editor, when you restart it, it always uses the default map. I prefer to have the last map I was working on to open. So it's load at startup. So instead of project default, you can select last opened. And asset editor open location, yes. Asset editor open location. This is something that by default I don't like, because if you go here and you open, for example, static mesh, it will open a new window, the static mesh editor window, and it will open it in full screen as a new window. I prefer it to be a panel from the main interface, and for that there is a parameter like always, and it's in main windows. Open it in the main window. Did I set everything alright? I think we are good. We need to restart. We restart later, okay. And now we are ready to start preparing the game. First thing we need to do is the game mode and the player controller. When you are using computer, and especially in game creation, because there are a lot of elements composing a game, it's important to have a good organization. Even if you are used to messy environment and you like chaos, you will lose a lot of time if you don't have a good organization inside your game. By organization, I mean the folder structure and the nomenclature of the assets, the naming convention. I don't know if nomenclature is a real word in English, probably. So here, it's we don't need to display the engine content, so we can hide it for now. Yeah. Here in the content browser, you have all the assets used in your game, and we decided to add the starter content, and we will make also a new folder, MakeSenS, and in this folder there will be everything we need for our game, everything we create by our own. I prefer also to have a little bigger icons, and I like to make my folder a certain color to recognize what is mine and what is from outside. For example, if you're using Megascan assets or assets from the Epic Games Store, yeah, it can be useful to have a different color to see. Well, it's just a possibility, you don't have to do that, but usually I put two different colors for the assets I'm using, and we will have a bright yellow for the external assets and green for our assets. And so in MakeSense, I was using blue for the, okay, it's fine. In MakeSense, we will need a game folder where we put all the game features and elements, and we will also give it the same color and create our game mode. So the game mode is responsible for the overall, for the general rules in your game, like player progression, what happens when the player dies, giving objectives or missions to the player, etc. The world generation, this kind of stuff. It's necessary. You can have several game modes in your project and switch from one to another depending on the actual game mode the player can experience, like multiplayer, cooperative, last survivor, I don't know, horde game. So here we can create a new blueprint class, and it will be a game mode base. There are several game modes you can inherent from. The normal game mode is more suited for multiplayer games, and the game mode it has some other functionalities. For now we will just stick with the game mode base. And the naming convention, as I was saying, everything I made in my project have the initial of the game project, so it's easier when you're searching assets to find them. And there are also game convention for saying what kind of asset it is. Here it's a blueprint class, but it's mainly a game mode, so GM, and it's just game base. When you have this sign, the asterisk, it means the asset is not saved. So you can right click and save, or save all here. I modified the chair? No, I don't think so, but okay. Let's save. So the game rules and logic will be inside this, but basically for now we will just give the information of what is the player controller we are using and what is the player pawn we are using. Let's make the controller. So player folder with a nice color, and we will create a new blueprint class, the player controller class. Yeah, as I can say, it's responsible for controlling the pawn used by the player. So it's more or less the interface between the player and the character in the game. So MK PC, and what was the name I gave? I try to stick with player controller, player base. Fine. And here we will resave the inputs and transmit them as a and call function inside the pawn to make the character move and jump. We also will do a very basic level. So level, we will create a new level. So we will start with new level, and no, basic level will be okay. Create, and I'll just remove the clouds. I don't care about the clouds, and we will gain some performances. Let's just save it. Save current level as NK LBL base to 1. Not this one, this one. Yeah. Come on. Okay. Am I I'm not monitoring? Okay, I'm filming, right. So I can display this again. Okay, sorry. Once we have this, yeah, something important to do is to tell the game that we are using this game mode. So we go in the project settings, we go in map and modes, and we select our game mode base. Also, editor started map and defo game map, we will use base level we made. It's not super important, but it's done. Yeah, so now we have our game mode that is used. We can take a look at what it is. Basically, it's a blueprint with nothing special, except there is parameters here defining what we are using. And for the player controller, we will use our player controller base here. We can compile and save, and we can try. Let's try. And you can see that I can move my camera, and I can use the keyboard controls, or even the controller, to move the player. But I didn't create any player. Once again, we are using the default pawn class here. So what we need to do now is to create our own character. In SenS, I'm using first-person view with body awareness, as I told you. I like first-person view for the immersion, and I wanted to add body awareness, even if it's very basic at the moment. It's just for prototyping the main game features in the game, so I don't need to have a super nice character. I'm using the mannequin character from Unreal Editor, but I'm planning on the future, and I'm thinking globally about the game. And as it's exploration game with a lot of importance given to the movement, I thought that the body awareness will be necessary for having a better perception of the environment and the space and the scale of things. Mirror Edge is doing that very nicely, because it's a parkour game, and you see your body, and the body is interacting with the environment, and it's give a better sense of presence in the game. Also, I had some comments on MakeSenS-001, my previous game, because of player having difficulties to evaluate the jump distance because they were not seeing the fit. Personally, I have no problem when playing a first-person game with platform section, maybe because I played a lot of first-person game and a lot of Half-Life with its slippery movement and platforming sections. But I understand that some people can have some difficulties. So having the character to be visible will probably help for the platform section, even if I don't plan to have very complicated platforming. Just for making simple jump, it will be better, and for the immersion. All of that to say that we need a character, so we will import the character from the third-person view template. For that, we can go here and add content pack, and we can select third person, add to project. Okay. That's all? Okay. There is 3 folders actually. I'd like to make everything in one single folder. So Unreal Engine third person, we will give it a color. Oh, I don't like the yellow one. Let's give a blue one, and let's change this to be a blue one too. And let's change colors from these ones to be the blue one. Okay, let's put all this folder inside one, so we can move them. And when I was talking to you about the importance of naming convention and organization, You have to know that in the old days of Unreal Engine, changing the name of an asset was kind of pain in the ass. It was risky, and even deleting an object was complicated. Now it's way more easier, but as you can see, even when I'm just moving folders and content to another, that because there are references between each elements, you will have some little issues. It's easy to fix. For example, here we have all the folders, as you can see, but some folders are remaining, and these are empty folders actually. So why the editor is not deleting these folders? Because there are redirector inside these folders. Redirector informing the game that, okay, this element, for example, the character mesh, it was previously inside another folder. And this redirector, you can't see them. Actually, you can display them. I don't remember exactly how, but you can see them in the actual. Let me show you that. For example, if we open the Explorer, here we are in our project content. This is the new folder where I put everything for the third-person view, and these are the old folders before moving the folders, you know, and they are empty in the editor, but actually if you go inside them, you will see there are assets, and these assets are the redirector. We won't delete it by hand, it's not great, but instead what we can do is go in our content, right click and fix up redirectors. Now you can safely delete the remaining empty folders, because if you watch now, for example here we see there is no more assets, so we can delete them and have a clean organization. Okay, so what is nice is we have now a character that we can use for our game. Okay, everything is fine. So yeah, I'm checking if I'm not forgetting stuff. Yeah, the importance of movement in exploration game, for climbing, for jumping, for having a better perception of the scale of the distance. I told you about that. And now I'm a bit lost. Sorry. Yes, we create the character. So, Pawn is a term used by Unreal to give a name to every playable or non-player playable characters. It can be animals, it can be a human, it can be a car, anything that is having a kind of intelligence, not intelligence, but behavior. So we will create a new blueprint, and this blueprint will be a character instead of a pawn. Yeah, pawn is an actor. Actor is all the elements used in Unreal, and pawn can be processed or receive input from a controller, whether it's a player controller or an AI controller. And the character is a specific pawn having a movement component and a capsule component for the collision detection, and a skeletal mesh for the actual representation of the character. MK car, I could, yeah, car is okay. Human base, yes, yes. Oh, a pretty face. Let's yeah, let's open it. First, before opening it, we will go in the game mode and we will select it. So instead of default pawn, we will use our MK character human base. Very well. So now, if we try to play in the editor, you can see I cannot move the camera anymore, I cannot move at all, because we have no movement functionalities inside the character we just made, the human base. But we can see something, because by default you have a camera created by the game controller, I guess. Where is my content browser? Yeah, here. Let's open this too. So yeah, basically the character is just a collision capsule. Let's have a camera. I used to call my component CNP what component they are and give them a name. Here, first person view. And we will put this camera, it should be something like this for first person view. But for testing we will put it a bit backward, so we can check if everything is going alright. Yeah, so if we make our capsule component visible by turning off hidden in game, and if we try the play in game, you can play in game from the blueprint, but we will have a very small, yeah. We can see our capsule component, we cannot move, we cannot do anything, and now the point of view is using the camera from the pawn. Let me just change the parameters for the view. Always center, and command resolution we will make 1080p. So now if we are playing, yeah, it's better. First things, if we want to be able to move, we need inputs. And for the inputs, we will make a new folder. I like green for my folder. Yeah, the new system in Unreal 5, if you're used to Unreal 4, they switch from the before you would have your input in the project preferences here, and you will be able to add new inputs. Yes, there are already some, but now they are using a new system which is more versatile, and it's a little bit more complicated to do, but just a little bit, and it's better. If we go in the third person character, I think if we go here, yeah, you will see they made the input. So you have input mapping context, which is responsible to attributing a key from the controller or the keyboard or the mouse to an action, and you have the actions themselves. The actions themselves are very simple. You can copy all this inside your our input folder, but we will create them from scratch. It's very simple. Should be simple. I just want to have the same name as on my demonstration project, my cheating sheet project. It's very okay. Input action. Yep. So NK input action, and it will be move. Yeah. Yeah. Fine. We will create. No. Let's just configure this one. The value type will be vector 2D. So two direction, X and Y, both positive and negative. And where is my content browser, please? We can duplicate this one for the look. So the camera movement. And it will be also a 2D axis vector. And we can create a new one, or we can duplicate this one for jump. So these are the different inputs we will use for the game. The jump need to be Boolean, because it's just jumping or not jumping. It's just a button pressing input. We can save all actually. Okay, there is nothing more to save. And then we need to attribute key to these inputs. So let's create an input mapping context. Yeah, that's right. E and C, and it's player base. Player base. Okay. We can close this. And we can start by adding by adding the inputs. So the first input will be move. And for move, here we can add control bindings, so key to press to use them. Move, we will use, also you can select your key press here by searching for them, or you can press on this button and then press on the right key, for example up. As I'm FPS player, I prefer to use ZSQD. In English it's WASD. So let's add the W for forward. Let's also add the French keyboard equivalent, Z. Then we will make the down for backward, which is S in both England International Keyboard and French keyboard. Left will be also A, and will be also Q, and right will be also D. Very well. Let's add a new input mapping for the look. Oh, I put AI move. It's the basic one that you find in the third-person project, but we want our own inputs. So change this. Look. look, we'll be using... Oh, by the way, sorry. Let's add also the controller input. I'm using a old controller, Xbox controller. It's fine enough, but you will see later that there are some little issues. I will talk to you about that. And for the controller, if you press the button here to select the key value and try to where is the camera? Try to move the stick, you will see that you will have only one axis, and we want both axes. Remember, it's 2D axis. So for that, we will have to manually select it. So it's left 2D axis. Left thumbstick 2D axis, sorry. So it's fine for the movement. For the look, we want the mouse to the axis, and we also want opening everything. Why do you open everything? The gamepad right thumbstick axis. Okay. And finally, yeah, don't open everything. I think there is a parameter. No? Oh, anyway. And yeah, for that we want to attribute the action jump. And we want the key spacebar. And on the controller we want, I don't know, maybe the left trigger, no, right trigger perhaps. Okay, whatever you want. But we have our controller now. In order to receive the controller, we have to do a little bit of code. You can see that in the third person character there is already a player controller, and we can see in the code of this player controller that at the begin play, when the game starts, there is this event inside the code of our character. This event will fire and will attribute the mapping context and unsaid mapping context in order to be able to resave the input action. So we will do that, but in the player controller. So you can copy this part, it's fine, but we don't need the part with the player controller. And we can pass it in our player controller in the event graph at the begin play. Yeah. So you drag the link here. Here I think we need a reference to self. I'm not sure, but I think so. So let's get a reference to self. And here we don't want this one, we want our one. So this input mapping context. So with this, we are able to receive the information from the controllers. Let's see if it's working. First we can search for input action, we can search for input action move, input action look, and input action jump. Several things interesting in this event graph, event node. But the one we will use will be the trigger one, when the player is actually pressing a key or moving the mouse or the joystick, and the value. What was my plan? Yeah, making the simple one, the jump one. So you can see here it's a 2D vector, and here it was a boolean. You remember we set that earlier. What do we need? We are in the player controller. We need to communicate with our pawn. For that we can get controlled pawn and cast it as our controller pawn class, and then give call functionality or modify variables. As we will do it several times, we will at the begin play make a reference to our controlled pawn. Let me check if I'm doing that alright. Yeah. So we cast this generic controlled pawn to our controlled pawn MK. You see, with the prefix MK it's easy to find it back. So that's the reason it's useful to have a prefix inside your assets, even if it's taking more space in the character name. And here we have our controller, so we can promote it as a variable and name it controlled pawn, and then after we can call the input. And we can make a comment. You can select nodes and press C, and it's good for organization and to find back things later when you come back in your code and you didn't saw it for a long time. It's useful to have this kind of comment sections. What's the name? Get pawn ref. Meh, don't save when I'm raw. The autosave things always happen when you're writing something. Get pawn reference, and then add the input mapping. So we can compile, and now instead of doing that every time you want to call a function inside your pawn from the controller, we can just take the variable and call the function from here. Can we call the jump function? Yeah. So, if we try now, we should be able to jump, yes. A jumping capsule. Okay. As I told you, in the character, you already have some functionalities for movement, and jump is handled by the character movement component, if I'm right. Yeah, it's handled by this, but it's also in the base. Yeah, you also have some parameters in the base character parameters, default class parameters. Something interesting is here we are using the trigger, because if you remember our input action for jump, which is just a simple we didn't make anything special. So here is the way your action can trigger, and we can have, for example, just a pressed trigger parameter. So every time you press the button, you will have the action to fire. But we can also have a press and release. So we can make another one, release. So when you press, you will have an action, and when you release, you will have another one. And if we go here, you can see that when completed, meaning when you release, you can have another action. For example, you can do the stop jumping on complete. Let me check if it was done this way. No, it's just for... Sorry. So if we try now, okay, something interesting to see is to see the code while we are playing. So we will see exactly what is happening. If we play and we press Shift F1 and we go here and select our controller, the ones that have been created when we start playing the game, we can see, okay, when I press, there is a the trigger red output is fired, and when I release, the completed is also fired, but also the trigger red. Trigger red is actually fired in both cases. If I just want, when I press, I go to the started one, and it should be working. Yeah. Fine. But it doesn't change anything, as you can see, inside the jump itself. I mean, I always jump at the same height, whatever time I press the button. This is because of the parameter for the jump inside the character, and you can see the max hold time is defining that. If you have 0, you will jump the same way whatever time you press the button. But if you make 1, for example, you see that now the jump force is applied to the character as long as I press. If I just press a little time, it's normal jump. If I press longer, I continue to ascend. This is not something I want in my game, but it's just to demonstrate you how it's working. Also, you see you can have multiple jump. If you make 3, let's say, you can make triple jump. Let's reset this by default, and as I said, we will have just a simple jump for now, so we will just use the trigger one. It was just to demonstrate you how it was working. And actually we won't make it this way, so we can even delete this one. What I prefer to do is to make a jump function inside my character, in the code of my character, and to call this function. For the jump, it will be the same as calling directly the pre-made jump functionality, but for the movement or for other functionalities that I will call by the controller, it's better to have a proper function. So you can go here, create a new function. What's the name I gave? I gave move. controller input jump. And from here, we will call the jump if we can. Yes, we can. So, very well. I'm correct. So it's exactly doing the same now. If we go here and we call the function jump, we will have exactly the same result. By the way, we can remove the release key. Alright. Maybe we will jump 2 times. Let me see. No, it's fine. Yes. If I press and release later, I jump 2 times. So let's delete this one. And we will make a comment here for inputs. We are good. So now the jump is made. Yeah, fine. We are ready to continue and to make the move function. So for this, we will go directly here. We will create a new function. Move controller input movement. And this time we need also to have an input in our function, because we want to transmit this value, the axis value, to our function in order to know how much we need to move. So let's create a new function, a new input. It will be input value, and it will be a vector 2D. While we are here, we can also, no, let's do it in the right order. So if you take our controller pawn and go here and call the function and move movement controller. Okay, I found it. And we give it the value from the controller or from the keyboard. We can go directly inside the character function by clicking it from another blueprint. It's very handy. And for doing that, okay. Yeah, you know what? We will just copy it from here, do exactly the same. So we will just copy the forward movement. Let's take this part. And it's using the y-axis, yes. It will be longer than I expected. Sorry. I was trying to make a short video, but it's still not the case. And here we can break this value to get only the y-axis, like that. Or you can also split the value directly in the same. You can recombine whatever. So the 2D vector is actually 2 float parameters, one for y, one for z, one for x, one for y, sorry. And if we plug that here, you can double click on the link to create a reroute node. It's very handy for organization purpose. Yeah, I like when it's clean, but you don't need to spend too much time on this. So what is happening inside the third-person code? We have the inputs when we press a key or move the joystick, and we add movement. So it's very easy, it's already made. You can, because we have a character movement, we can, or because it's a pawn, you can just add movement. But we need a direction, and the direction is actually the controller rotation and the Z value, so the horizontal rotation, meaning if we come on, okay, if we put our controller in the game, or character in the game, you can see the Z axis is the one going top down, but it also means it's responsible for the horizontal rotation. But what is strange here is we are not using the character rotation, we are using the controller rotation. It's common way in Unreal to use the controller rotation, but you also can get actor rotation and split the rotation variable, and it will be working exactly the same. So what is it doing right now? If we start playing, I press up, nothing happening. Press down, nothing happening. And if I use the controller, okay, the controller is giving some information. Actually, it's alright because going forward or backward is working. But then, why it is not working on the keyboard? It's because of this part. We need to attribute some modifier to the key we press. By default, it's doing just on-off, but it's not doing a direction. Yes, it's doing 0-1 in the direction. But by default, it's doing it. And if you remember, this action is move, is a vector 2D. And when we press a key, something is happening. Let's see what is happening actually. We can make a print and see that, and we can observe the value we are giving to the pawn. If we play, yeah, you see? When I press a key, actually every key we mapped to the movement, it's always giving x1. While with the controller, yeah, you can see, and we noticed something interesting, you see? I told you before it was an odd controller, but first, let's see if it's working. Yeah, it's working. We have 1 in Y direction when we are going forward, and backward it's -1. So yeah, the controller is mapped this way. Forward, backward is Y, and lateral movement, left and right, are on X axis. But inside Unreal, forward, backward, come on. Yes, okay. If you go here, you can see that the red axis is actually X, and the Y axis for the lateral movement is actually Y. This is something you can switch one with the other. It's not very important, so there are several ways possible. We can use X instead of Y. Please. Yes. And you can see that now, if I press any key, oh, I'm going forward. Okay. I'm not going backward, we didn't make the code for the lateral movement, but I'm always going forward even if I press the down key or the S key. And you can see now with the controller, if I go up or down, it's doing nothing, but if I go left and right, it's doing the job. So this means we have to change the way that we are receiving the input and transforming them into variable for the player controller and then for the character. For that we go here, and what we have to do, yes, let's first address the little issue we have with the controller. To do that, we will have a modifier, and the modifier will be dead zone. What is doing dead zone? It's not reading inside the future in your mind. It's just doing that when you press the joystick, you will have to press up to a certain level before recording the values. And also I'm putting 0.9 for the upper threshold, because, yeah, I told you it's an old controller, but even in the brand new controller you can have this problem of when the joystick is on the... I don't see the camera. Yeah. When the joystick is on the middle, when you're not touching it, it can give a little bit of datas, of values. It won't be always 0 y and 0 x. So if you put this dead zone modifier, you are sure that when you are in the middle, nothing is happening. So it's pretty useful to don't have parasited input. And then what we have to do, okay, for up, do we use the Y for going forward? I don't remember what I did in the other one. Yeah. No. Yeah, forward was X. So what we have to change is not up. Up is fine. We have to change the down. The down will need a negate. So instead of being +1, it will be -1. And it will be on the x-axis. It's the same way for the S. And then we also need while we are here to do the left and right. At the moment, left and right are also giving x-axis, so we have to tell the engine that we want something different. We want to invert x and y. This is the swivel input. It's doing exactly that. You can see swap x and y. For left, it will be -1 on the y, so let's also add a negate. Let's copy both and pass them on the A and pass them on the Q. And for the right, we need only to swivel. what I'm doing. And we can save. And for the gamepad we need to swivel to in order to have X on the forward backward. Fine. So now we should have the right input. Let's try. Forward, backward, okay. Up, down, Z, S. S is not negative. Y is forward. Should be right. And the right and left are not giving, you see, they are giving the right information now. Left -1 in Y and right 1 in Y. But what is doing S? S is doing 1. Did I forget to put negate? Yeah. Down, negate. Okay, I did it here only. So let's just copy it so it's done quickly. No, it doesn't want to copy it. Okay. Negate on X. Up, down. Okay. So we have our movement. Now we need the lateral movement. So it's pretty much the same way. We can copy this, or you can create it by from scratch. I mean, it's add movement input, and we get the right vector. Okay, right vector. We split this. This is the raw direction we want our movement. We want the Y for the scale value. And we want the, well, as I told you, we can use this one, which is the actor rotation, or the control rotation. Let's use the control rotation for now, and I will show you that it's working exactly the same. Which one it is? This one? Let me check. Yes. So now we should have the lateral movement. If we try, okay, all the keys are working. And on the joystick, yeah, on the joystick it's working. Very well. And I can show you that you can, instead of having the controller rotation, you can have the actor rotation. It's the same. But we will use the controller rotation as they do on the third-person blueprints. For several reasons. We are not far away, but I want to show you something interesting. If we go in the playing game, you see that I go forward, okay, I go on the right, okay, but if I go both forward and on the left, or on the right, sorry, or on the left, or backward, the vector are 1, 1, or 1, 0. 1, 1 when you go in two directions at the same time. But on the controller, you see, if I go sideways and forward at the same time, I more or less have 0.7, something like that. So maybe the speed is different, the speed of my character, because I'm adding, with the keyboard, I'm adding 1 and 1 instead of 0.7 and 0.7. Let's check that. You can get velocity for the character. You can turn this 3 variable vector into distance, vector length. Okay. And this will be the speed of our character. Let's print both. No. Yes. Let's make it clear. Okay. Input values. We will plug the values and we will have speed, and we will plug this here. So it's a way to have a bigger string and have several information at the same time. Okay. You can see that the speed is 600 whatever direction I go. And it's a bit strange because, yeah, I'm adding 2-time movement. I'm adding movement at 100% in the X direction and in the Y direction here, for example. So I would accept the speed to be different. And on the controller, okay, whatever direction I go, even if I add only 0.7 when I do bidirectional at the same time, the speed is also always at 600. So the reason is my character max speed is set here, you can see, at 600 centimeters per second. And even if I actually input a larger value, I'm not sure what I'm saying. Even if I put larger value, the speed limit is 600. But let's make a little test. If we divide the input value by 0.5, by 2 actually. I was thinking about multiplying by 0.5, but it's the same. Let's see what is happening. Okay, 300 in both. But if I use this, you can see now the effect of having a non-normalized vector length for the half direction, would I say, is making the character to go faster. You see? We are going at 400. This is not super important, but it might cause issues and you might wonder why you are going speeder using the keyboard than using the controller. So the easy way to fix that and to have the same value from the controllers and from the keyboard is to normalize our vector. And you can see now, if we check the values, with the keyboard we now have 0.7 and the speed is clean, and it's the same with the controller. Okay, that was just a little detail, but might be useful for you and sometimes you might be wondering what is happening. Now you know. So we are done with a basic movement for the player. I should watch you more often, sorry. It's hard to remember that you're not a camera but a real person, and I'm talking to you in a different time and space. Okay, we did everything, I think. Okay, now there is a little interesting... no, it's for later. Now we need rotation. And we will do the rotation after a little pause.